Problem one, we're talking about outputs in this playlist. This is the output study guide playlist. So the first problem says the following population parameters were obtained from a graphing calculator. This is the output from one variable stats. So it's this idea when you're in the calculator, you go to the statistics menu, the stat menu, to enter some statistics. You enter some values, 15, 4, 8, 9, 7, 2, whatever you enter, right? You go over to stat. You go to calculate one variable statistics because there's only one variable here, these x values. And you hit enter again, and then it gives you those one variable stats. So this is essentially the same output that you see in the graphing calculator here. You see x bar, you see the sum of the x values, the sum of the x squared values, the sample standard deviation, the population standard deviation, and then n is the number of values that you input. So this is the traditional one variable stat screen. But here, so the problem is cut off, but I can give you an idea of what kind of thing would be asked here. So assuming the population is bell-shaped, another way of saying that is normally distributed. Right? Bell-shaped, normally distributed. Essentially, we're saying the same thing. Approximately what percentage of the population values are between, and then have two values here. So let's talk in general about the normal distribution. Let me draw something. Where do I want to draw it? I'll draw it here. I'll draw it here. I'll draw it here. I'll draw it here. I'm going to try to do this well. Let's see if I can get a good... Okay, that's not too bad. I think I should draw it quicker. So if I do it quicker, I'll be less apt to kind of make a mistake here. So this is a bell curve, a bell-shaped curve, otherwise known as a normal distribution. In that normal distribution, the way this is set up is right in the middle is our mean, population mean there. And this is delineated by standard deviations. So this is one standard deviation above my mean. So it's essentially my mean plus one standard deviation. And then if I go again, that next interval is my mean plus two standard deviations. And then one more, my mean plus three standard deviations. We only go to three standard deviations. Anything above that is considered an outlier. So we only go to three, which is standard. Then on the left side, if I'm going left of the mean, that's my mean minus one standard deviation, trying to make this even here. My mean minus two standard deviations, and here 3 standard deviations away from my mean, less than my mean. So we go 3 standard deviations above the mean, 3 standard deviations below the mean. Now these very specific values away from my mean, these are important values because certain things happen here. So let's say, so 1 standard deviation away from my mean. When I say 1 standard deviation away from my mean, I mean between 1 standard deviation below and 1 standard deviation above my mean. So in this region here, when we're talking about a normal distribution, 1 standard deviation away from my mean, about 68% of my values are in that interval. 68% are 1 standard deviation away, between 1 standard deviation below, 1 standard deviation above. If I'm going 2 standard deviations away from my mean, 2 standard deviations away, so that's 2 above, 2 below or 2 above, about 95% of my values are there. And I'll go down a little bit more. And then if I say, let's say 3 standard deviations below, or 3 standard deviations above my mean, about 99% of my values are there. Now, depending on which textbook you look at, depending on what resource you use, you'll get more specific values than that. But you know, that's why I say about that. You can get like very, very much closer. You can get a better rounding there, but this is sufficient for us. So, okay, so for each of these, for number 1 and number 2, I'm going to do number 2 in this video as well. I'm going to redraw this normal distribution, but specifically for this situation. And it can be done relatively quickly. Here we go. Oh gosh, that's bad. Let me fix that. Let me fix that a little bit. Nah, that's probably just as bad. So for this specific situation, what's my mean? And in this case, we're using the sample mean, which is okay. Mean is 59. Okay. So I'm going 1 standard deviation above that mean. And again, my population standard deviation, mu, is 10. So 59 plus 10 is 69. Another standard deviation above my mean, that's 2, 79. Remember, we always go 3. 3 standard deviations above, that's 89. And then I do the same going in the other direction. Below my mean, so minus 10 is 49, minus another 10, that's 39, and subtract another 10, that's 29. So what can I say here? I can say that 68% of the population values are between 49 and 69. Do you see why? That's 1 standard deviation away from my mean. So here, that's 68%. 68% of my values are between 49 and 69. About 95% are between 39 and 79. That's 2 standard deviations below, 2 standard deviations above. So that's about 95%. Between 39 and 79. And 3 standard deviations away from my mean, 99% of those values. That's, so about 99% are between 29 and 89. And this 39 and 79. I don't know why I wrote 75. Don't judge me. Let me fix that. Erase that. Between 39 and 79. Sorry. So this question probably said, assuming the population is bell-shaped, approximately what percentage of population values are between, and they probably use one of these intervals. They use one of those intervals, pretty easy to do. There's a lot of symmetry going on here. So if I asked you what percentage of values are less than 59, that's exactly 1/2 of this normal distribution. So you'd say 50% are less than 59, 50% are greater than 59. You can do more. I'll just mention it, but I won't go too deep. 68% are 1 standard deviation away, right? I can split that 68% in 2 and say about 34% are here. About 34% are here between 1 standard deviation and the mean, 1 standard deviation below the mean and the mean, and 34% are here. So if I got even further and asked you what percentage are between 49 and 59, 34%. And the same symmetry applies all the way down. So there's a lot of interesting questions we can ask. These are the most basic ones, including 50%. But there's a lot of stuff we can ask there. Let's look at number 2. More stuff we can ask. So the following population parameters were obtained from a graphing calculator. Same 1 variable stats, but we're looking at just a different set of data there. assuming the population is bell-shaped, again, normal distribution, between what two values will approximately something percent of the population, I don't know. So they'd give a number here, possibly one of these values, 68, 95, 99. But you know how to construct that already. So you can very easily, and I mean, you can do this without constructing this distribution, but where's the fun in that? So my mean is 77. We'll go 1 standard deviation, 2 standard deviations, 3 standard deviations. I know this drawing is not to scale. So our standard deviation here is 8. So we're adding 8 on the right side, subtracting 8 on the left side. So 77 plus 8, that's 85. 85 plus 8, that's 93. 93 plus 8, that's 101. Subtracting 8, that's what, 69. Subtract another 8, that's 61. And subtract another 8, and what do we get there? What's that, 59? 50, what? I'm drawing a blank. It's 53, isn't it? Yeah. So 99% of my values are between 53 and 101. 99% are between 53 and 101. 95% are between 61, that's 2 below, and 93. And 68% are between, and this is approximate, right? 1 standard deviation below and 1 above, that's 69 and 85. Let me take a peek at the answer sheet here and see if any of my values are answers to these questions. Yeah, so the answer sheet has this interval here. Has between 69 and 85. That's the answer. So I assume this question was asking, assuming the population is bell-shaped, between what two values will approximately 68% of the population lie. So 68% will be between 69 and 85. That's the answer to the question there. So there you go.